in StatCrunch. So PowerPoint 3, hypothesis testing 3, is performing the tests with StatCrunch. So last time we saw how to set up the tests, and now we're seeing what do we do to complete the tests. So again, going back to our outline for hypothesis testing, we're going to make a statement regarding the population mean or proportion. And we looked at doing that last time when we were making out what is the null hypothesis and what is the alternative hypothesis. Collect data and compute the sample statistics. That's where we did the next stage last time, where we wrote down what was our sample data that they gave us in the problem. Step 3 is to analyze the sample data to assess if the data is sufficient to make a conclusion. We learned how to analyze it, and now we're going to learn how to get it, and then we'll make the conclusion. So steps 3 and 4 today. So let's go back to our example from last time, the hypothesis test for the mean. According to a Nielsen Company audience report, an adult person in the US spends approximately 10 hours and 39 minutes each day on screen time. This average of 10 hours and 39 minutes, or 639 minutes, includes our daily use of smartphones, computers, video games, radios, tablets, and TVs. It's believed that students at your community college spend more time on screens each day than 639 minutes. So a survey asked 25 students to record their screen time, and they record a mean screen time of 655 minutes and a standard deviation of S equals 41 minutes. Is this unusual enough to provide sufficient evidence that the screen time of Bristol Community College students is more than recorded for adults in the US? Perform a hypothesis test with alpha equals 0.05. So that's the new part at the end. Our step 1 is to make a statement regarding the population mean or proportion. So we state our null and alternative hypothesis. Our null is that the mean is 639, and our alternative that we think is true is that the mean is greater than 639. We draw and shade the normal distribution. We practiced that last time and saw that it was a right-tailed test. So now we're going to go into StatCrunch. We're going to compute the data and sample statistics. All we needed is a random sample greater than 30, and we're going to do a t-stat. So just like we did with hypothesis testing, it's a t-stat when we're talking about the mean. We'll do t-stat one sample with summary just like before, but now we click the radio button for hypothesis testing and we fill in all the information for the hypothesis test. So we fill in that our null hypothesis is the mean is 639 and our alternative that the mean is greater than 639. And that's it. And out pops our hypothesis test. It just repeats the null and alternative here in case you typed in something, you had a typo or something. And then it's going to give you your test statistic and your p-value. Okay, so this is my test statistic. The reason I'm telling you it's a test statistic is sometimes in Pearson they're going to ask you for this. So that's for Pearson. Okay, any questions? And then we do the final analysis. We analyze the sample data to see if the data is sufficient to make a conclusion. Because the p-value in this case was 0.03, that was less than alpha equals 0.05. So we reject the null hypothesis and accept the alternative hypothesis. And our last step is to state the conclusion. We have sufficient evidence to support the claim that the mean number of minutes of screen time is more than 639 minutes. Okay. So let's look at a proportion problem. The hypothesis test for the proportion. According to the national census, 24.5% of all U.S. residents who live in renter-occupied housing units lived elsewhere 1 year prior. Because needing to move while attending school is believed to negatively impact student success, your community college decides to learn if the rate of moving is less for its students. A survey finds that a random sample of 1,004 students results in 228 who have moved in the past year. Is this unusual enough to provide sufficient evidence that the rate of moving for Bristol Community College students is less than the national rate of 24.5%? Conduct a hypothesis test with alpha equals 0.01. So we make the statement about the population mean or proportion, stating the null and alternative hypothesis. The null is that the proportion is 24.5% or 0.245. And the alternative that our claim is it's actually less for our students. So P is less than 0.245. So we have a left-tailed test. A less than is shaded on the left. So into StatCrunch we go. And just like when we were doing the confidence interval, we're going to use proportion stats. So that's going to seem really familiar. Proportion stats, one sample with summary. Again, it opens up where we have to put in our successes and our observations, but this part is new, where we have to click on hypothesis test and put in our hypothesis test. P is 0.245 and P less than 0.245. Out will pop the data or the results that we have the test as we put it in before. We get our Z statistic, and this is our test statistic. And our p-value. If you need to check initial conditions, it's just the same as it was when we were doing the confidence interval. We need to have a random sample. We need to have less than 5% of the population, and we need to multiply n times p hat times 1 minus p hat and be bigger than or equal to 10. So we can check that. So because the p-value is 0.09, which is greater than alpha, which was 0.05, we cannot reject the null hypothesis and cannot accept the alternative hypothesis. So our final conclusion, we do not have enough evidence to assert that the proportion of Bristol Community College students who have moved this year is less than 24.5%.